All right, so today the experiment that we're going to do is we're going to try to determine the empirical formula of copper oxide. So copper, we know, can either have an oxidation state of +1 or +2. So we're trying to figure out if this copper oxide is CuO or Cu2O. So the first thing that we want to do is we want to take a 150 ml beaker and we want to get its mass. So I'm going to zero the balance. Okay, and then 67.87 grams. I'm going to record that in my notebook. Next, I'm going to add anywhere between 2 and 2.5 grams of the copper oxide. It doesn't matter exactly how much you add, but you do need to record that mass. Okay, so I'll get my scupula. Okay, and now my mass is 69.94 grams. So I added a little bit over 2 grams. Again, that number is going to get recorded in my lab notebook. All right, now I need to sort of dissolve the copper oxide. It's not very soluble in water, but we're going to add hydrochloric acid in a minute. But first, we're going to add 25 milliliters of just deionized water. So my wash bottle. Don't have to be super exact here. We're not interested in the molarity. Okay. Yep, right about 25 milliliters. So I'm gonna add that. And then I'm gonna get my stir rod. Here. Remember, when you're stirring, you never want to just stir without holding onto the beaker because you could move the beaker. So you always want to hold the beaker while you're stirring. So we'll give this a good stir here. And like you can see, it's not dissolving super well, but that'll change once we add the hydrochloric acid and then ultimately the zinc. All right, so next I want to add 25 milliliters of 3 molar hydrochloric acid. So I'm going to grab another graduated cylinder here. Again, I don't need to be super precise here. It's about 25 mils, so I'm not going to use a pipette or anything like that. Okay, yep, that looks good. All right, and I'm going to slowly add it. And continuing to stir. Now, this is going to take a bit. I need to stir this for a little while, so we need to be patient. So with the copper oxide, it can be difficult to tell if it's all dissolved because of the dark color. So one of the things that you can do is you stir for a while, but then let it settle and see if some of the solid starts to fall to the bottom. And so what you can see here, see how it's lighter up top and it's darker down below? So what that's telling me is that there is still solid, that it hasn't fully dissolved. So now I need to continue with step 4 and add a little bit more hydrochloric acid because I need to get all of this to dissolve. So again, I'm going to take my 3 molar hydrochloric acid and I just want to add it in small increments. I don't want to add a bunch of extra hydrochloric acid that I'm now going to have to deal with my waste when the reaction is done. So I add another few milliliters of the hydrochloric acid, and then I go back to stirring it. So this is going to take a little while until we can get all of this copper oxide to dissolve. Okay, so I'm going to be stirring here for a while. All right, so now that I've dissolved my copper oxide in the water and the hydrochloric acid, I need to add my zinc to cause the reaction to happen. The zinc is going to react with the copper oxide and reduce the copper to copper metal. So here is my 3 grams of my zinc. I want to add this carefully. Hydrogen gas does get produced here, so that's why we need to make sure there's no flames around. Just make sure we get it all in there. So we can see and hear bubbles that are forming, right? That's the hydrogen gas. Okay, so you can see the zinc at the bottom starting to react with that copper oxide. So now this needs to be stirred for 10 minutes. So I'm just gonna keep stirring. All right, so after I have stirred, now what you can see is the copper metal is at the bottom. You can see the solution is now colorless. So we lost that, dark blue, almost black color, but we still need to confirm that all of the copper oxide has reacted. And so what we're gonna do now is we're gonna take a piece of shiny zinc metal as opposed to the granular zinc that we added. And we're gonna dip this into the beaker. If the reddish brown copper metal starts to form on this zinc, that means that there is still unreacted copper oxide that once I add the zinc, it reacts with. And we need all of that copper oxide to react. That's our limiting reagent. The zinc that we added was excess zinc to ensure the reaction went to completion. So I'm just gonna dip this in, just kind of hold it, not a super long time. But what I see is, okay, nothing has formed on the copper metal, or sorry, on the zinc metal. So I know that this reaction is complete. And so now what I need to do is I need to quench the excess zinc metal that's in here. Because when I filter my product, I don't want it to be copper metal and zinc metal. I need it to just be the copper. So what I'm gonna do is I'm gonna add excess hydrochloric acid to react with any of the unreacted zinc. That'll cause the zinc to turn into zinc ions and go into solution so that my solid will just be the copper metal, the product that I want. So I'm gonna take another 25 milliliters of my 3 molar hydrochloric acid. And again, hydrogen gas will be produced in this step from this single replacement reaction. So see the bubbles forming. And again, going to stir, make sure that I get a complete reaction. I really need to make sure that all of that zinc metal is reacted. All right, so again, I'm gonna be here stirring for a while. All right, so now that I have quenched my excess zinc, you can see in the beaker here again, that reddish brown solid, that's the copper metal. I need to collect my product so that I can weigh it and use it to determine the empirical formula of the copper oxide. So I have a filtration set up here with a funnel. I'm using a ring stand and the iron ring just to make it more secure so that I don't accidentally knock it over. And I'm gonna take a piece of filter paper and I need to weigh it. I'm gonna also try to hold it by the edges just so that I don't get any oil or grease from my fingers transferred over to the piece of filter paper. So I'm going to zero my balance, weigh my piece of filter paper. It weighs 1.09 grams. So again, I will record that number in my lab notebook. And then what I'm gonna do is I'm going to do what we call flute the filter paper. So it's a way of folding the filter paper. And the point of it is by creating the folds, you create more surface area for our product to stick to. So the way that you flute filter paper is you first fold it in half and then in quarters. like so. But then what I'm gonna do is I'm gonna take it and fold it back on itself, like this. And then I'm gonna do the same thing over here, like that. I'm gonna do this one more time. It's normally all you can really get out of it. So again, fold this back. You can try to do it a third time. Doesn't always work super well because the paper at this point is pretty thick, but try to get a few more folds in there, like so. Okay, now we open it up and we have all of these nice folds for my product to stick to. So I'm gonna put it inside my funnel. I'm going to wet the filter paper a little bit just to help it stick to the funnel. So, and then what I'm gonna do is now I'm gonna filter my product. So in order to have this go a little bit quicker, what you wanna do is you first wanna decant, which means try to pour off as much of the filtrate that's on top as possible. Get that done first, because as soon as the solid is in here, it's gonna slow the rate of the filtration. So you just want to carefully pour such that the solid actually stays at the bottom of the flask. That's what we call decanting. And so this is just a gravity filtration. I'm not using a Buchner funnel and doing a vacuum filtration here. So since we are relying on the force of gravity, it does go a little bit slower as opposed to pulling a vacuum and speeding up the filtration. All right, so I'm gonna take a couple minutes here to filter as much of the liquid as possible. I'm gonna leave a little bit so that I can use it to help transfer the solid, but like I said, try to get most of the liquid decanted off. So now you can see most of the liquid is gone. And so what I'm gonna do now is I'm going to stir it and then transfer it quickly into the funnel so that the solid transfers with the solution. Like so. Now you can see that not all of the solid has transferred. This is my product. I need all of it to get onto the filter paper. So what I'm gonna do is I'm going to use, this is what's called the filtrate. I'm gonna use the filtrate to rinse the beaker so that I, again, can do my swirl and transfer. Probably have to do this 2 times, maybe even a third, depending on how the transfer goes. It's really important that I get all of my product onto this piece of filter paper. Otherwise, I'm not gonna get the correct empirical formula. So I'm just gonna, again, take my filtrate here, just pour just a little bit, because the more, I don't want to pour all of this back in because then I'd have to filter it all again. So just again, swirl, transfer. You can see it's better, but still have some of my product stuck into my beaker. So like I said, I'm going to let this drain a bit. And then I'm going to do this one more time, possibly another time. We'll see how it looks. And I can even raise this up just a little, make this a little bit easier. Okay. And so I really want to get a good, really just some momentum as I stir it. All right, so I still have a little bit left. The other thing that I can do is I can use my scupula to kind of scrape some of it in. I'm going to do that as well. And then I'll give it one more rinsing. So at this point, I've gotten most of it. I said one more rinsing ought to do it. All right. Okay, and now I transferred all of my copper product onto my filter paper. So I'm going to let this finish filtering, and then I'm going to take out my filter paper, kind of spread it out so that it can dry faster. I'm going to put it on a watch glass so that I can set it aside and let it dry completely. So my copper product, I've collected it onto this filter paper here. You can see it has that reddish brown color. I'm gonna let this dry completely. It's mostly dry, but you can see it's still a little clumpy. That tells me that there is still water present, and I don't want that water to artificially increase my mass. But once this is completely dry, I'm gonna record its mass, subtract the mass of the filter paper, and then I'll know exactly how much copper product I made. I'll then use that mass to then ultimately convert into moles of the copper, and then use that to determine the empirical formula of the copper oxide.